Okay, so welcome everyone to this Dell Colloquium Talk. I am very happy to introduce the speaker of this event, Mark-Matthias Zymla from the University of Konstanz. And I asked him about his status now, whether I should introduce him as a PhD student or something. And I know that he's no longer a PhD student. He has defended his dissertation in March. So, but because of some official requirement, he is not allowed to carry the title PhD. So like his official designation is Doctor Designatus. I've been informed, so I'm going to be precise. Okay, so like he has to do some formal requirement, but he has obtained his PhD in this March at the University of Konstanz. And his main research interests are all sorts of issues at the interfaces of syntax, semantics, and pragmatics, especially from a computational point of view. And today he's going to give his talk, Contextualizing Tense Aspect Features, a cross-linguistically informed approach to capturing their meaning. We are recording this talk, so after the talk we can have some discussion, question answers section. If you don't want to be featured, then in that section just turn off your camera, or you can also send your question in chat to me and I can ask. So Mark, okay, so welcome online to our department, and the floor is yours.
Okay. Hi, everyone. Thanks for the nice and very precise introduction. As Peter said, I'm interested in tense and aspect cross-linguistically, and I identify as a computational linguist. So a lot of my issues are also concerned with how to implement stuff that we learn about these languages. Today I will talk about two main things, which I will present in a second, but some of them will be more theoretical and some of them will be more computational. Okay, so I don't have to tell you that there's a wide variety of different languages in the world, and they have different kinds of ways to express stuff about the past, the present, and the future, basically anchoring eventualities somehow in space and time. So yeah, many languages means many strategies, and I don't have to tell you that as linguists. Here's just a couple of examples to see, okay, how could we express things? And that's basically what my thesis was about initially. It's called Tense and Aspect in Multilingual Semantic Construction, which is about the cross-linguistic variation of tense and aspect, particularly from a semantic perspective. And one thing that I have thought a lot about in the course of my thesis, which has emerged as a recurring topic, is the contextualization of tense and aspect. And what that means, I will explain in more detail later on. I will also later on talk a little bit about lexical functional grammar, but I have kept that part a little bit smaller. But I will also have to talk a little bit about formal semantics, because the kind of computational linguistics I'm interested in are formal computational linguistics. So there will not be much about the latest trend of large language models, but rather more conservative traditional approaches to encoding linguistic information computationally. Right, and I said that a couple of times now. It's about the syntax and semantics of tense aspect forms. This is the overall structure of the talk. I will give you a little bit more background on how I got into this project and into this topic. The first part I have dubbed Understanding Tense and Aspect, which will be the more theoretical review of what we know about tense and aspect, talking about cross-linguistic variation of tense and aspect, what I mean by contextualization, and then we will start going towards the direction of formal syntax of tense and aspect, because that is something that has already been researched a bit more computationally, but the semantic part was what was still open when I started my project a good while back. So this will be the second part, basically what I did in terms of computational work for formal semantics and tense and aspect, mainly talking about semantic annotation via linguistic rewriting. Okay. By the way, if there's any questions or something is unclear, you could also stop me during the talk if it's really bad. So please let me know if anyone gets lost. Let's try to keep everyone on board. But now I will start with the background. Okay, so see, maybe I can move you guys really quick. So I started so all of this originated from a project called the Parallel Grammar Project, which some of you probably have heard of. It is an international effort for developing rule-based, large-scale computational parallel grammars. So that's also where the name is derived from, parallel grammar, pargram. And the important part of this project was to derive cross-linguistically comparable analyses based on shared feature sets. And we will see a little bit of this later on. And there's quite a lot of grammars. There's large grammars for English, German, French, Norwegian, Chinese, Japanese, and Polish. Some of them still hold up very well. And even the smaller grammars hold up very well. We have them for Greek, Indonesian, Malagasy, Turkish, Welsh, Wolof, Urdu, Georgian, and Hungarian as well. To be fair, I'm not 100% certain about the progress of all of these grammars at this point. So some of them might be larger than I give them credit for here. But just so you know, has been a lot of people all around the world have been involved into developing these grammars, especially in the early 2000s. Okay. The project I have worked in is called the same name as my thesis, Tense and Aspect in Multilingual Semantic Construction, and is a daughter project of the Pargram effort. But this was more about the semantic research in Pargram, which has never been broadly applied to the various grammars, so it has never really taken off, so to say. And the idea of the ParTMA effort was to not do all the semantics at once, but come up with a focused effort on one particular aspect of semantics, namely tense and aspect. As you can see here, the original goal was to talk about parallel tense, mood, and aspect. But for my thesis, I've left out mood just because tense and aspect is already such a huge field that I only could scratch mood on the surface so far. We'll see what future research brings. And this project was also led by Miriam Butt and Maribel Romero as a collaboration between syntax and semantics. A little truth, a little admission about my thesis is that it became a little bit of a digression into semantics and computational LFG in general, because there weren't that many resources to do computational LFG semantics. So I have implemented a couple of resources over the years, which were also tailored more generally towards working with semantics and LFG, and I will show a little bit of that later too. Okay. So let's start with the first part, understanding tense and aspect. So we have already seen already established languages across the world vary in all kinds of ways, and tense and aspect is no exception. And one way where this has been shown extremely impressively is the very large-scale typological studies in the 80s and 90s. In particular, the study by Östendahl, 1985, is very groundbreaking, or at least it is one of the largest comprehensive systematic analysis of tense and aspect. And I'm pretty sure everyone who worked on the topic has looked at this work in some capacity. He analyzed 64 languages across the world, coming from 11 areal genetic groups, so based on area and ancestry. And what he did is he did multiple studies, basically. One of them was a translation study of sentences into the target language via a questionnaire. But he also did a more general production study where he asked people to describe their tense aspect systems in the respective languages, basically. So this basically where I started off many, many years ago, looking at this work. And then you are presented with some of, so I think we first look at the questionnaire. So it looks like this. What he did is he gave them a context and a sentence, and he always gave them the sentence in the infinitival form, so that they were not primed by the English language to translate it in a certain way, but had to come up with their own morphological marking. And then they had to translate it. And based on the production study that they did, they created an alphanumeric code for identifying used tense aspect forms. So when they used a form for translation, they also needed to make clear that they understand which form they have used. And then they got a large set of sentences to translate and to produce. Right. So like from this, he got a lot of information, what kind of context different tense and aspect forms may be used. And we will only look at some of his results very briefly, just to illustrate that it can be very daunting to think about tense and aspect cross-linguistically if you first start with the topic. So here we have what we would call grammatical or viewpoint aspect categories, perfective versus imperfective. And as you can see, the description of all of these forms is quite varied. So we have perfective here, which makes sense. We have aorist, which is more of a tense form. We have simple past, past simple. So some of these have overlap, but we have a lot of forms. And as you can see, we have past and we have perfective, but we don't really have much information about the imperfective here. Where did that go? Basically, it went to the past tense categories for some reason or another. Of course, I'm not trying to. So this is just to show that the classification of tense aspect forms can be quite difficult, but you can see here there's a lot of different imperfective and imperfective forms, which are all in the table of past categories rather than in the perfective, imperfect categories. So it can be really difficult to properly categorize these kinds of categories is the point that I'm trying to make with these examples. But this is also not surprising given the huge amount of variation that we have within the tense and aspect fields. Nonetheless, I recommend looking at the work because there's a lot of beautiful insights in there. And it's a good starting point to get an understanding of how big the field of tense and aspect is. Okay. Oestendahl also has shown these are basically forms of perfective, imperfective meaning, but they also have different kinds of semantics. And this is sort of represented in these tables here. We will not talk about them in detail, but the idea is here that there are different kinds of contexts where these categories should appear or not appear. And you can see here that these vary across the different languages. So especially here in the second part of the table, we see that there's a lot of variation between these languages with respect to which context specific forms are used for. Okay, so just as an overview, if you are interested, please look at the study. And when you start as a PhD student and you look at all of this, and it becomes suddenly very, very scary because there's so much variation cross-linguistically. But over the years and through more research, they can be derived into more basic building blocks, which makes them a little bit less scary, but not that much, to be honest. So the main morphosyntactic distinctions that we find these days in tense aspect categories are between inflectional forms, basically part of the verbal or auxiliary inflectional paradigm, periphrastic forms, which introduce a new lexical items, and derivational forms. So these are the three main distinctions that you find in the morphosyntax of tense aspect forms, but you also need to take into account quite a lot of additional considerations. For example, is that form optional? Can it be applied recursively? Are there any syncretisms with other forms? Because that might block certain meanings that are available in other languages. So it looks a bit more simple on the surface, but once you start delving into it, you see, okay, actually, there's still quite a lot of variation that you need to take into account if you want to produce a comprehensive cross-linguistic picture of the tense aspect forms. In terms of meaning, if we talk strictly about temporal meaning, it's not that scary. We have the typical distinctions between non-future, non-present, and non-past, and these can be even more refined to past, present, and future. Some of you might have heard that there's also additional categories like remote past or recent past, which refers to a past tense that is in the near past or tenses in the more remote past. But these are also just sub forms of past, present, and future. So here, there's nothing really too surprising going on. What's important is that many languages distinguish sometimes between one of these and then non-present to cover their inflectional paradigm, and then have an additional auxiliary for the last tense form. So this is a prevalent something, for example, happening in English, that we have, or not a better example is German, where you have a past and non-present distinction between inflectional past tense and inflectional present tense, and then you have auxiliary form for the future. But I'm digressing, sorry. Not too surprising in terms of the semantics. Grammatical aspect or viewpoint aspect is a bit more complex, I would say. First, we have the general distinction between perfective and imperfective aspect. And the perfective aspect is generally assumed to describe an eventuality as a complete whole, while the imperfective gives you a partial view on a situation or eventuality. And specific kinds of this are the progressive or continuous aspect and also the habitual. And you can see that there's a bit of more variation on the side of the imperfective aspect, because we have more fine-grained distinctions there, which boil down to different kinds of semantics possible with these features. We will not go into too much depth here, but if you want, we can talk about it later on. Okay, so some examples here, the very obvious ones. We have past tense in English and the present perfect, the present progressive, which indicates that something is currently happening, and the future tense. We can see in English the forms are pretty straightforward. Past and present are inflectional, while future tense is periphrastic, and the progressive aspect and the perfect are periphrastic. A short note on the perfect. I will not talk about it much in this talk. It is kind of a mixed form between tense and aspect. So it does not really fit in this distinction between perfective and imperfective aspect, but it also doesn't only fit into a temporal dimension. So for this, we need an additional kind of semantic description that I will not talk about in this talk. Okay. But we also have languages like Indonesian, which do not have any obligatory tense marking. So in English, the inflected tense is obligatory, but in Indonesian, you can simply say Peter menulis sebuah surat. I don't know how to pronounce this, but this is how I would pronounce this, which can mean Peter wrote a letter, Peter is writing a letter, or Peter will write a letter. There's some additional optional auxiliaries in Indonesian which can help disambiguate certain utterances. For example, there's a future marker akan, And there's also perfect markers, which can also be used as tense markers. The Taylor, for example, and we have sedang, which is the progressive mark, comparable to the progressive mark in English. I made a mistake with the glossing here. I'm sorry, but this is supposed to be the progressive. Okay, and then we have other languages with very pronounced tense aspect systems like Polish, where we mark both aspect and tense obligatorily. Aspect is encoded derivationally, as you can see here by the perfective affix na, and tense is inflectional, as you can see here with these examples. One interesting thing that we have in Polish, which also appears in a couple of languages, is if you combine the perfective aspect with the present tense, then you will not get a present tense interpretation, but rather a future interpretation. This is due to the particular semantics of the perfective. If you recall, we said a perfectively marked eventuality is described as a complete whole. However, since the present is merely a moment, it is difficult to observe the whole eventuality within this short moment of the now. And this means we shifted to the future, as you can see here. And this is also a result of there being a dedicated past marker, so it wouldn't make sense to move the perfective here to the past. So as you can already see, there's a lot of kinds of different interactions in the paradigm that you need to take into consideration when working with tense aspect categories. Okay. So now let's talk about contextualization of tense aspect. Basically, what we have now is we have forms of tense aspect categories and we have meanings. So like here we have a Lego piece and we give it a meaning warm. This is nice and all, but this is also exactly the problem. The meaning that we give to these things that can vary on the context, basically. So as you know, this kind of Lego piece can be used in all kinds of different combinations to create all kinds of interesting and nice things. Of course, grammatical forms and categories are not as unrestricted in their use, but the metaphor, I think, still stands. We can't really just look at this piece and call it a worm. We have to really look how the piece is used in different kinds of constructions across the language. And this is where contextualization comes in. So the underlying idea is that the form to meaning mapping is not one-to-one, but rather one-to-many. And this is true for lexical items, as you know, but also actually, or even more so maybe for functional elements. This has been shown also more recently by research on how large language models handle functional words and categories. And what has been shown there, to sum it up very briefly, is that actually it's much harder for language models to capture the meaning of these functional categories because they are so much more contextualized compared to the simple lexical semantics of, for example, nouns or adjectives or verb phrases. Not verb phrase, but verbs. Right. So we sort of know from different sources and also from the older literature that tense aspect forms can get quite different meanings on their depending on their broader syntactic and semantic context. So there's a couple of simple examples from English, which I have presented in one of my first papers in 2017. Back then, I didn't use the term contextualization yet, but it fits together well with how these effects are described in the literature I just mentioned about large language models, and that's why I have adapted this term in my more recent work. For example, the English past tense has this weird quirk of called sequence of tense, which happens if you embed a past under a past in a complement clause, under a prepositional attitude verb. So for example, here we have the prepositional attitude verb say, and we have Sam said that Jordan was visiting her mother. This can, in this case, mean two different things, namely Sam said Jordan is visiting her mother, or Sam said Jordan was visiting her mother. The important thing to note here is that it can't mean Sam said Jordan will visit her mother, even if it's still in the past. So you can think about it in a way that the tense of the matrix verb say here blocks serves as an upper boundary of the temporal span of the embedded verb. So it can go up to when the saying happened, but not beyond it. Is that more or less clear? Okay, thank you. Similarly, the past tense has another meaning in English when combined with certain verbs. For example, here wish. Jordan wished she had a fast car. Here, due to the semantics of the word wish, the past tense here receives a counterfactual interpretation, which also has an effect on its temporal interpretation. Namely, this is more visible if we look at the counterfactual conditional, which is a similar effect. If Jordan had a fast car, so counterfactual here means it's not true, then she would be very happy. And this means it is about either the present or the future, but we are not talking about the past anymore here. And this means that the meaning of the past tense that we see here in different contexts can actually be quite different from a temporal perspective. It can either mean non-future or non-past in these kinds of contexts. So this is one type of contextualization. However, there are more. And it's also noteworthy that not all contextualizations are universal across languages. So different languages contextualize differently, and this is based on the inventory of the tense aspect system that we are talking about. So for example, in German, we can express the examples that we've seen before with the counterfactual conditional and the wish modal like this. Jordan wishes she would have a fast car. So as you can see here, I also just translated a bit differently just because this is marked differently with hätte, which is a subjunctive form in German. So we have the same thing in the counterfactual conditional. If Jordan had a fast car, then she would be happy. Here we also have the subjunctive form, which is independent of the past tense form in German. So we have a bit of a different encoding here and don't get this kind of counterfactual reading of the past tense in German. Already before I mentioned that there's even more context dependence going on, which can be clearly seen by languages that get along without any tense aspect marking on their verbs. And you can still, from the context, infer whether it's about the past, present, or future. But this also is true for languages with tense aspect features. And the understanding here is that these tense aspect features serve as constraints on contextual reasoning, but the contextual reasoning can further refine the temporal anchoring of an utterance. A way to show that this is contextual can be shown by a famous example by Barbara Parti. I didn't turn off the stove. If we assume no context dependence whatsoever, then this sentence has two possible meanings. One where the negation outscopes the temporal information, saying it is not the case that there's a past time where I turned off the stove. And this is, of course, a very strong assertion, which is almost certainly false, because every one of you will have at some point probably turned off a stove. However, the other way around, if we let the temporal information outscope the negation, then we say there's a time such that it's not the case that I turned off the stove. And in this case, this is almost trivially true, because just 5 minutes ago I was here talking, so of course I haven't turned off the stove then. And this goes for basically any arbitrary time interval in the past. So this is trivially true, and can also not be the right thing. So when we use a tense form, we are not talking about just any old time in the past or in the future, but we talk about very specific forms. This becomes, oh, there's no breaks here. Okay, this is for tense, so this is more refined. And if we go to aspect, we also get something that you could argue are kinds of contextualization. At least it involves the morphosyntactic and semantic context of the tense aspect form and changes the semantic entailments accordingly. For example, sorry for a second. I have a visitor. She will be gone in a second. Let's give her a moment to see what's going on, and then I will continue talking. Sorry for that. Yes. No biting, no playing now. No. Hey. Okay. She was not too happy that I forced her to go. I'm sorry for that. But let's get back to the talk. The chicken was crossing the road, a kind of progressive sentence can be continued with the clause when it was hit by a truck, suggesting that this does not talk about the completed event, which is in line what we learned about the semantics of the imperfective earlier on. This can be made more clear with the pair of inferences that are called the imperfective paradox, that maybe some of you have already heard about. If you combine the progressive with a kind of eventuality that has a inherent endpoint, like drawing a circle, at some point the circle is done, so it has this inherent endpoint, then the progressive does not entail that the endpoint was reached, as indicated here by the alternative interpretation of the simple past. However, if we have an activity, so an eventuality without an inherent endpoint, like pushing a cart, or a car in this case, pretty strong person, this Jordan. So let's say Jordan was pushing a car. It does actually entail that she pushed that car in some capacity. Similarly, we can do the same with path prepositional phrases, like Jordan was walking to the store. This does not entail that Jordan was at a store at any point. However, if we say Jordan was walking in the park, then that entails that Jordan walked in the park. So these are also two kinds of ways to indicate that an eventuality has an inherent endpoint, and you can see that this property affects this inference pattern. Another thing that we also observe is that here we have the simple present tense in English, but this does not entail that Jordan is writing a letter. In English, the simple present tense is generally, in particular with combination of a plural object, an indicator for habitual aspect, which indicates that she does this, but not necessarily now, but rather as a regularly occurring hobby or eventuality. So as you can see, different forms of aspect are also, and tense are still contextually influenced by what happens around them in some capacity. And this is not only within a sentence, but continues to work across sentences as well. So here's a famous example by Escher and Laskaridis. We have two very similar pairs. John fell, Max helped him up, and John fell, Max pushed him. We have two, for each of these, there's word knowledge involved that helps us arranging these two eventualities temporally. Here, the apparent interpretation is that first John fell and then Max helped him up. And here, John fell but Max pushed him, so the pushing was before the falling. The caveat here is that the simple past in English indicates perfective meaning, so we always get a kind of sequential reading, but the sequence is, depends on our world knowledge of the relation between these two eventualities. So now we are sort of leaving the area of contextualizing tense aspect features and go more into the area of contextualizing the whole eventuality. But the tense aspect features still affect this to some extent, which we can see with some more examples. Again, here we have a sequence. Jordan wrote a report, she submitted it, which clearly indicates that these things happen one after another. But if we introduce the progressive in the second sentence, then we get an overlap. So Jordan wrote a report, and the typical reading is that she was listening to music during the writing process. Similarly, if we combine the first perfective utterance with habitual utterance, again here introduced now with the past tense, but also with a plural object. So you see the plural object again plays an important role in interpreting the tense aspect marking on the verb. Then we get a sequence here again, but that is because of the different kind of relation between these sentences. So here, this sentence is about the childhood and not about its relation to the remembering. So it would not make sense to assume that this sequence is the following. John remembered her childhood and then she started to collect comics. No, it's about, this is an explanation of what she remembered about her childhood. So what happened here? That looks interesting. So what we have seen is that perfective aspect is used to describe sequences of eventualities. Imperfective aspect allows to express overlap between certain eventualities. Here there should be an example. Let me look it up. I think I have it on my on the proper slides. I'm not sure what happened here. Okay, I must have accidentally deleted it, but it was something to the effect to this, something like Jordan lived in Paris when she was young. To earn money, she collected coins or something. Sorry, I'm not good with coming up with examples on the fly. In any case, it is an example of overlap between the perfective in the first sentence and habitual in the second sentence. So what we see from this is that the interpretation of these eventualities hinges on the one hand on their tense and aspect marking, but also on the world knowledge we have about certain eventualities. And this can be encoded, for example, via discourse relations, which is what the book by Asher and Laskaridis is all about. So I also recommend looking at that if you are interested in more of the pragmatics of tense and aspect. Okay, so we have seen there's a lot of variation cross-linguistically. I haven't talked about it in detail, but some trends emerge. For example, the progressive is usually shown as an auxiliary category. Past tense often, but not always inflectional. For example, there's other trends, but this is not my main research area, and there's a lot of people who can describe these trends better than I do. But for us, importantly, that we have seen that syntactically and semantically, tense and aspect has been reduced to a small number of concepts. What makes it still complicated is that there are still a lot of possible configurations depending on the specific tense and aspect system in a given language. And we also have seen that these semantics are based on contextualization. So we can't simply say a form has a certain meaning, but the meaning of a form depends on its context to a strong degree and on various levels. And these are roughly the syntax, semantics, and pragmatics. I will not say too much more about the pragmatics in the talk, because syntax and semantics, getting them right computationally is already quite a challenge. So the pragmatics are basically a part of an ongoing research interest of mine, which I maybe can talk about a little bit more later if you want to. Okay, so let's get to the to the last part of the first part, formal syntax for tense and aspect, where we talk about how tense and aspect was analyzed within the Parkrun project. So we go back to the parallel grammar project we have mentioned before, with the goal of crafting cross-linguistically comparable parallel grammars. And we will focus first now, as I said, on the syntactic aspect. It uses lexical functional grammar as underlying theory of the syntax. We will see examples of that in a second. What's important to note is that we have two different kinds of syntactic structures, and one of these varies across language very strongly, the C structure, whereas the F structure remains relatively invariant. The F structure, as we will see in a second, will have also another role of serving as the input to further semantic processing, and which means, okay, she provides features ready for semantic interpretation. And actually, as I will also hopefully show in the next few slides, to take away one of my conclusions is that that it is not as easy to simply use these tense aspect features that Parkrun proposes to do semantic reasoning. We have seen that there's a complex interaction between morphology, syntax, and semantics. And another factor that has been troubling researchers on tense and aspect across the world was auxiliary selection, which has its syntactic factors, which have been researched inside and outside of LFG a lot, but also semantic factors as shown, for example, by Kratzer and Ramstein and Svenonius, who show that there must be some kind of semantic general structure underlying these auxiliary selection facts. So let's look at an example of this. Generally, in English, if we want to stack auxiliaries like the perfect and the progressive, we have to do this in a certain order. We can't say Jordan has leaving, but we have to say Jordan has been leaving. And this means that different kinds of auxiliaries select for what comes after them. So the perfect selects for basically a bare eventuality or a progressive eventuality like we see here. And we can represent this in a very traditional way in this C structure here on the left, where we have the hierarchical structure reflecting the auxiliary selection facts. Now in LFG, we also have the F structure. And in early approaches to LFG, what we see is that the F structure basically mimics the structure of the C structure. We have our perfect auxiliary on the outside, and it has a closed complement forming the progressive, so the VP here, which again has a closed complement, which is just the verb. So this kind of hierarchical structure we see here is also the same hierarchical structure that we have on the left in the more traditional C structure representation, which is also similar to what you would get in other syntactic frameworks. Now, what Parkrun went and did is, okay, it said, yeah, the C structure is fine. We need that kind of information to capture the facts of word order in that language, so we do it in that way. But we don't really want to reflect this kind of word order information in the more functional, in the more abstract F structure. So what they did is they reduced this information to functional features. So we get here a present tense feature from has, we get a perfect feature from also the auxiliary with in combination with the VP, and we get progressive by from this VP here as well. I will not go in detail about the exact formal mechanics behind this, but what's important to note here is just that what they did is they reduced information from the surface structure in the F structure to gain more abstract functional features representing these categories. And then the idea that Pargram had is that once we have this, we can simply say, okay, let's translate this to a semantic representation, here a discourse representation structure. And I will not worry about translating the whole eventuality. So we have Jordan, we have some time which corresponds to now. We have a reference time which overlaps with the now, which is given to us by the present tense, which tells us, okay, there's a time which overlaps with the now, but the perfect tells us that the eventuality that we are actually talking about precedes the reference time. So Jordan has been leaving at some point before the reference time. And we know that this thing was ongoing at that time we are talking about. The agent of the whole eventuality is Jordan, and it's a leaving event. So basically, there's again what we said before, this kind of one-to-one correspondence between form and meaning. We have a present feature, so we get a present feature in the semantics. We have a perfect, so we get something that corresponds to the perfect in the semantics. And we have a progressive, so we get something for the progressive in semantics. But I hope that I have shown so far that this is definitely not what is enough to do semantic analysis of tense aspect features cross-linguistically and even in one language. What Pargram did well and what they achieved in terms of their goals is that they kept language-specific idiosyncrasies out of the F structure. So we have a very abstract representation of which is comparable across languages with respect to the features. And in very simple sentences like that, like what we just saw, maybe they are semantically interpretable in the correct way. But we have seen that this very quickly breaks down if we think about how tense aspect features are contextualized. So to interpret functional features, we really need the syntactic, semantic, and pragmatic context. We can't just rely on the feature itself. So I have tried to summarize this in this kind of diagram here. So what Pargram did is it looked at all of these languages and tried to find a common name for similar features. So it bundled all of them up, for example, here, these examples, into the past tense feature. But what we know from tense aspect research is that, okay, this can mean a whole lot of things. In the right context, it can mean a perfective viewpoint, but if combined with a plural object in English at least, it can mean imperfective, and so on and so forth. So actually, all of this kind of bundling of the language variation here to one type of feature requires us then to actually unpack this information that has got lost after bundling the feature. So what you can think about, a way that I try to think about is that these functional features serve as a pivot point for parallelizing analyses. However, this kind of bundling is a cost that we pay for. We have a cost to pay, which allows us to reduce these complex form to features. But once we want to semantically interpret these features, then we have to repay this cost by again contextualizing them. And this is basically what I tried to do in my thesis. So let's go on to the second part of this talk, where I talk about how I try to implement a formal system that is compatible with lexical functional grammar to contextualize functional features in the theory. And since I've already been talking quite a while, I try to keep it as compact as possible. The overall goal of my thesis was to implement an annotation scheme for tense and aspect. basically mainly focused on sentence level annotations. So the input is our morphosyntactically annotated sentences. I will focus here on LFG, but I've also worked with other kinds of syntactic frameworks, in particular universal dependencies. And what is basically novel about my system is that it's a layered annotation of the syntax semantics interface with a cross-linguistically viable feature space. And the layering is ultimately what gives us the possibility to contextualize functional features. In addition, at some point, okay, we can say we have semantically contextualized features, but we still need a semantic interpretation component, which produces semantic representations for evaluation. And so let's start with the first part, the multi-layered annotation. So the multi-layered annotation gradually increases the context in which a functional category is evaluated. And in the process, semantic values are rewritten as more information becomes available. And rewriting values may not always be theoretically super adequate, but is maybe sometimes. For example, you could make an argument for sequence of tense being a case of semantically rewriting a simple tense aspect feature, but also you could make the same claim for counterfactuals as has been shown by Romero 2014. However, what was also more important for me at the time is that it makes stuff more simple on an implementational level. Because this means you don't have to write a complex algorithm about which rules to apply. You just apply all the rewrite rules, and what remains at the end is what you want in terms of an analysis. I will try to explain this with only one simple example for this talk, namely sequence of tense, which we have also seen before. It has two distinct readings, namely we can have John said that Mary was sick can mean Mary is sick or Mary was sick. And the kind of rewrite schema that we want to apply here is, okay, first of all, we have two instances of past tense, so we want to have a semantic past tense feature. However, as we have seen, there's some kind of constraint on the embedded past tense, so we want to add an additional contextualization rule that rewrites the embedded tense, here highlighted by the subscripts, into a non-future relative to the matrix tense. And this is the schema that I will try to explain in more detail in the next couple of slides. So first of all, this is the kind of syntactic representation that we get. On the left, we have the F structure, which gives us John as the subject for the verb say. We have a complement clause, and the complement clause is headed by the verb to be sick, which has Mary as a subject. And importantly, both of these elements are marked with past tense. We can simply understand this as a graph, which is shown here on the right, which is exactly the same information on the left, but in a graph structure. And I added this kind of representation because the system I've developed for developing these rewrite rules is basically a graph rewriting system that takes as input a graph and then adds additional information. So everything that's read here is added by the rewrite system. So we add information about temporal reference, so the semantics of tense, information about aspect, and also about verb class, which we have seen played a role in the imperfective paradox, but which will not be super important for us in this example. And we add this for both of these nodes here, one for the matrix verb and one for the embedded verb. And then we can start specifying features that rewrite our features into what we want. So here's again the schema. We want to rewrite past tense into a past temporal reference. And in the implementation, it would look something like this. What's different between here and here is here that you can see that we have identifiers for the particular nodes in the graph that we want to apply this rule to. And we'll see on our next slide how this would look. So we want to find a tense aspect node. And if we have that, we want to find its semantic projection and add temporal information that we want to rewrite the temporal information we have there into a past tense. So basically what we do is we have a rule here and we say, okay, this is past tense. We want to check for the semantic projection and the temporal reference node. So you want to rewrite anything in this node here, and the same happens here in the embedded clause. And then we get, but then we need to also apply the second level of contextualization. Here we do this by checking for what's called inside-out functional application. So what this means in principle is we look for an embedded past tense, and we check whether this tense is governed by another instance of temporal reference. So if we look at a graph, it becomes a bit more clear. We are here, we check for this the semantics of tense here and see if this is governed by another level of past temporal reference. And in this case, if this happens, we rewrite the instance to non-future. So in principle, formally, it's all not very difficult. You just have to develop the right rules. What is a bit more tricky is, okay, we have the appropriate features now, but now we want a semantic representation to build off of that. Quick question, can I go a bit over time or should I come to a close?
I think we have time. So yeah.
Okay.
Classes begin at 2 o'clock. So I think we have half an hour.
Okay. So this is a bit unfortunate because this is probably the most complicated part of the talk. So, and I need to probably speed up a little bit. So what we want to do is now we have semantic features, but we want to also create meaning representations. What we do is we use clue semantics, which is the semantic formalism of choice for LFG. And composition in clue semantics is guided by resource management. What this means is we have one part of the meaning representation that manages the combination and one that manages the meaning. So our resource management comes from linear logic as combination logic, and the meaning language, which is a particular property of LFG, of clue semantics, is that it can be any kind of semantic representation that allows similar processes to lambda calculus. So we can use first order lambda calculus or lambda DRT or other variations of lambda calculus. And to explain this, here we have meaning constructors for the sentence John loves Mary. So John gives us a resource G, Mary gives us a resource H, and our verb tells us, give me something that is a G and give me something that is a H, and I'll give you something that is an F. So this tells us I consume a G and an H to produce F. We can write this as this kind of derivation as proof tree. First, we combine G with loves, so because whatever is here fits in here. And on the meaning side, this corresponds to a functional application step. So as you can see here, we have dropped the lambda and replaced X by John as part of the functional application process. And we do the same thing with Mary. And then we get the meaning for the full sentence, John loves Mary. So this is a very simple example of clue semantics. And as I said or indicated, is based on the relation between linear logic and semantics, which is called the Curry-Howard isomorphism. We have seen what happens on the right side if you combine something of type AB with A. Then on the meaning side, we do functional application, as here indicated by F being applied to A. However, we also, as you know, if you're a bit familiar with lambda calculus, we have lambda abstraction, which means you can introduce a lambda term over a variable. And this can happen if that variable has been used earlier as a placeholder. In GlueSmax, this kind of placeholder is called an assumption. So we make an assumption that the resource A exists, but because linear logic is resource sensitive, once we make that assumption, we must at some point reintroduce it again to make sure that it's actually properly processed. So if we make an assumption but never discharge it, reintroduce it, we would basically hurt the principles of linear logic. So this means once we do an assumption, we actually need an element A somewhere in our derivation that allows us to fill this slot. And I will try to explain this with quantifier ambiguity. So every man kisses a woman is famously ambiguous between two readings. There's one woman that is kissed by every man, or every man kisses a different woman. And this is the F structure for it. And our verb looks like the following. We identify our agent with the object, our patient with the object. So the second argument here is our patient. We align our first argument, the agent, with the subject, and we get the semantics for the full F structure. And if we align this with these indices that we see here on the F structure, we get this kind of representation, which looks a bit more friendly. Now we do the same thing for the quantifiers, which becomes a bit more tricky. For the quantifiers, we introduce a bit of additional structure here, which allows us to build the quantifiers like this. What's important here is that we have something that consumes the restrictor of the quantifier, for example, here man, and gives us the meaning of every man, which we can apply to the scope of the quantifier, namely the rest of the sentence. So here, as you can see, man fits neatly in this slot here, so we can simply combine those to get every man. This means we get all of these kinds of meaning constructors. We get the verb, we get every man, every man is here, and we get a woman. And now the question is, how can we make sure that we get both of the readings of this sentence? And this is where the lambda abstraction step comes in, the step of making assumptions. For the first reading, what we do is we make an assumption about the existence of the object, which gives us then something of type of this type, which is compatible with the quantifier a woman. So we fit that in there, and we get the meaning there's a woman and something kisses this woman. As you know, we have made an assumption here, so we have to reintroduce the corresponding resource. So we reintroduce M, which is the assumption that we made up here. And then we have again something of this type, which is now compatible with the consumption type of our universal quantifier, which allows us then to compute the meaning of the full sentence. This is the first reading, the surface scope reading of the sentence, where every man outscopes a woman. Now, if you want to have the inverse scope reading, we make two assumptions in the beginning, both for the subject and for the object, giving us the meaning of the verb, but with these assumptions. So we have to do something about the assumptions. We discharge this time the subject first, so that we can combine our verb with the quantifier over the subject, every man. That means we get this kind of representation again. We have to do a second discharge operation, which gives us the type that makes it compatible with the object quantifier, a woman, which ultimately allows us to derive the meaning there exists a woman such for every man they kiss that specific woman, giving us the inverse scope reading. And to recall, we did this by mapping these kinds of meaning representations onto nodes in the F structure. And basically, we want to do the same thing for our semantics that we have for the tensor aspect information. So for this, I've developed a computational system to illustrate this, which takes in information from the syntax and then does the semantic annotation as a second step, and then gives us all of what I've just shown you for this kind of annotation. And I will just give you a very small demo of that, and then I'm actually done with my talk. So generally, what happens is that the grammar provides a semantic skeleton, and then we add additional tense aspect information via the rewrite rules that we have seen in the talk. Okay, let's have a quick look, and then I will wrap up the talk. So for all of this, I have also developed a web interface, which will be put online next month. As you can see here, we have quite a couple of windows. On the left side, we have our rules that we have seen in the talk as well for rewriting tense. And we have also rules for creating meaning constructors, as you can see, for example, here. So we have rules that tell us, okay, given a specific kind of annotation, create this kind of meaning constructor. And if we execute this code here, the machine starts calculating and creates a very complex graph of the whole annotation, and then gives us the meaning constructors that we have also seen in the talk. And then in a second step, this doesn't really look like a meaning representation yet, so don't worry about the different available options here, but we want a DRT representation. So we calculate the semantics, and we actually get our quantifier ambiguity as we have seen in the slides. And this also works for some more complex tense aspect examples, for example, where we would expect this kind of sequence of tense rule to apply, rewriting the past into a non-future. And if we actually execute this, let's remove this here to then we get the meaning constructors that are associated with that. And if we calculate the semantics again, we now see that we get the same semantic structure that we would expect, namely that we have a matrix verb in the past, which is also perfective. And we have the progressive in the embedded clause. And we know that it is relative to the matrix tense. So here x5 is our matrix event. So relative to that, it's in the non-future, and it is ongoing during that time. So as you can see, we sort of capture the information that we want to capture with our rewrite rules, which is here just a simple example, but just so you see, okay, this is kind of how it should work in principle, at least. Okay, I think I'll stop here. Thanks for listening, and I hope it was a bit informative for everyone.
Thank you very much. And now I can open the floor for the discussion part of the talk. So if you have any questions, comments, this is the time to come forward with those. Just speak up, or you can send them in a message as well. So does anyone have a question? I see, Avi, you have unmuted yourself.
Yes. Can you hear me?
Yes.
Yes. Okay. Hi. Thanks for the talk. So I have a question. So you seem to be focusing on the functional domain above the VP, but you also made reference to verb class.
Yes.
When you mentioned the imperfective paradox, because there's clearly a significant amount of interaction between grammatical aspect, as I think that's what you usually mean. In this talk, and event type. So how exactly is, you just mentioned verb class in that graph somewhere, but how exactly is that represented in your analysis? And like, there's like so much evidence for this interaction. Like, I will walk to the park in 10 minutes. is ambiguous, whereas I will reach the hilltop is not. So durativity is a kind of event type information. And this is just an example that shows that that's clearly relevant for the semantics. So how is that, do you know, or have you ever thought about this, or like how captured?
Yes, I have thought about it. It turns out it's a bit more difficult to implement computationally, which is why I have omitted it today, because it becomes much more complex to explain. But basically what I'm doing is decompositional event semantics a la Ramchand, which is what I present in my thesis as a proposal, basically decomposing an event into an initial phase, process phase, and a result phase. And then depending on the different kinds of configurations, we can derive different kinds of results. And basically the imperfective paradox arises from how we calculate these results.
Okay. Or also like impossible examples, like I was finding the key. I guess that's also something that you, how that is bad. That is, or I was breaking the vase. That sounds also quite bad. Okay.
Because these have resultative, built in, right?
Okay. Okay. Thank you.
Yeah, sure.
Anyone else? Question? I was wondering at the beginning when you had the typological picture, and you said that like languages can select all sorts of meaning components in these aspectual features. So are there any kind of generalizations about that? So like if, let's say, language uses an aspect form in a particular context, then it implies that it also uses it in another one, but not vice versa. Yeah, so like are there any like generalizations about these things? So like forms with functions. So was it just like languages randomly pick meaning components? I guess not, but I don't know.
So I'm sure there's more. So there's tentative generalizations. For example, usually the counterfactual interpretation of the past tense emerges as for lack of the subjunctive, for example. So I can just give like no systematic explanation of the interactions, but they were not the main focus of my work. For me, it was more important to come up with a way that can capture the different kinds of configuration of tense aspect features. So for example, if there's a configuration possible between some two features, then it should be able to capture it via this kind of rewrite semantics.
Right. Okay.
So yeah, in that regard, I'm not very like, I was really more interested in something that works computationally rather than going into detail about how tense aspect actually works and relied more on existing research.
I see. Yuri, you also unmuted yourself.
Thank you very much. It was very interesting. So if I got this well, then you were studying complex sentences with finite clauses. Mostly you focused on them. So I was just wondering if you looked into non-finite subordination, or you had some examples in the beginning where we have like something like a cross-clausal sequence of tenses phenomena, like, you know, with the remember example, like I remembered my childhood, and that's kind of, you know, backward looking, and other lexical items are kind of forward looking. So did you look into these things which could possibly be, you know, captured by LFG based parsers, or not? I don't know.
So yes, I have looked into these, and in principle, it is in principle possible. The only issue that you get from a technical standpoint is that it's a bit difficult to explain, but I'm actually working on a grammar that does this stuff and it works, but there's a lot of spurious ambiguity. I will not go into details where it comes from, but it is technically possible, but due to some limitations of how the syntax max system works, I have to figure out how to deal with I guess more technical issues rather than theoretical issues. But theoretically, it is not really a problem. If we look at the rules here, there's a couple of rules which deal with non-finite embedding. And basically, for now, non-finite embedding just means basically that the corresponding tense aspect information is missing. There's no guess at how to interpret it, but rather it's just omitted. I will not create an example here because I have not done it for DRT. I just have done it for plain lambda calculus, and I would have to change the grammar and stuff. But I wanted to, and on your other question regarding cross-sentential reasoning, that's basically why I'm working towards getting everything running in DRT, because DRT, from a formal semantic standpoint, is better suited for intersentential phenomena. And in my thesis, I have remained at a level of sentential phenomena. And also, if you look at my thesis, you will see that the semantics are all basically first-order lambda calculus. So this is basically a development after my thesis where I want to explore more also the pragmatic constraints introduced by tense and aspect.
Okay, thank you.
With pragmatic things, so how would that be handled? Because those are just implicatures, right? So like even those examples you had, like Max fell, John helped him versus Max fell, John pushed him. So those are not entailments. So like in principle, the sentence, those are ambiguous. So like both scenarios are compatible with the present or a posterior or anterior interpretation. So like that would, the computational model would assign some probability to one of the interpretations, or what would happen then?
So yes, on the one side, you sort of want to take a guess at what's the most likely sequence of events. On the other hand, what Asher and Laskaridis propose in their work is that they use what's called discourse relations. So, for example, you have something like elaboration usually entails overlap. So even if the tense and aspect allows overlap or sequence, if the discourse relation is that of elaboration, you would expect there to be an overlap rather than a sequence. So you have this interaction between different kinds of logics. And as you say, some of these are not are more implications rather than entailments. So that's why it's difficult to capture it plainly in these formal semantic frameworks that are designed for capturing this kind of monotonic reading at a sentential level. And that's why I, again, right now work towards DRT to make this system more compatible with these ideas about how to combine the semantics of different sentences. But to do this properly, you would also have some way of automatically annotating discourse relations between different sentences, for example, or different eventualities.
Yeah, and then I guess like the discourse relation would then raise the probability of one particular interpretation radically, perhaps,
or even rule it out completely. Yes.
Yeah. Like that, if you rule it out completely, then that's not. Then would that be an entailment? Or like if you rule completely, so like out.
I wouldn't.
So is there a scenario where you can completely rule out, like in the technical sense of the word?
I'm not completely sure. I would have to look into it again, but I think so. The way I'm going about this, I want to work with like packed representations, which means that we want to preserve information about different possible configurations in the context of other configurations. So we do not anticipate that something is ruled out completely, but yeah, it depends, I would say.
Right. Thank you.
Yeah, sorry, it's not a very satisfying answer.
Yeah, these are very complex issues. So like
so this is really something
answer.
I got more into more recently. So in some aspects I have to need to work a bit more before I can give like more intelligent answers. Sorry for that.
Yeah, thanks. Okay, any other question or comment from anyone? I don't see anything. I check the chat. No, nothing in the chat. Okay, so if there's nothing else, I would like to thank you very much for this talk. I think it was very interesting and
thank you.
Benefited it.